In this video, we are going to learn about stoichiometry. From stoichiometry, we can know that what will be the required mass of reactants in a given reaction and how much product will be formed. In this video, we will also understand that how to represent concentration of solution through mass percent, mole fraction, molarity and molality. Stoichiometry helps us to understand that in a given chemical reaction, what should be the mass of reactant and the mass of product formed. This can be understood from a balanced chemical equation. When methane and oxygen combines, then carbon dioxide and water vapor are formed. This is the balanced chemical equation for that reaction. In this equation, methane and dioxygen are the reactants, and carbon dioxide and water are the products. We can see that methane and carbon dioxide have coefficient of 1 and dioxygen and water have coefficient of 2. These coefficients are known as stoichiometric coefficient, which indicates the required number of moles or required number of molecules of element in a chemical reaction. So from this chemical equation we get to know 4 things. First, 1 mole of methane and 2 mole of dioxygen together forms 1 mole of carbon dioxide and 2 moles of water vapor. Second, 1 molecule of methane and 2 molecules of dioxygen together form 1 molecule of carbon dioxide and 2 molecules of water vapor. Third, 22.7 liter of methane and 45.4 liter of dioxygen combines to form 22.7 liter of carbon dioxide and 45.4 liter of water vapor. Here it is important to know that if 1 mole of any ideal gas is taken, then its volume at STP will be 22.7 liters only. For example, the volume of 1 mole of methane and 1 mole of carbon dioxide at STP will be 22.7 liters. And the volume of 2 mole of dioxygen and 2 mole of water vapor will be double of 22.7 liters, that is 45.4 liters. Here STP means standard temperature and pressure, in which the value of temperature is 0 degrees Celsius and the value of pressure is 1 bar. 1 bar is approximately equal to 1 atmospheric pressure. The SI unit of pressure is Pascal, and there are 10 to the power 5 Pascal in 1 bar. Fourth and last, 16 gram of methane and 64 gram of dioxygen combines to form 44 gram of carbon dioxide and 36 gram of water vapor. Since 1 mole of methane would have mass of 16 gram and 2 mole of dioxygen would have mass of 64 gram. Similarly, the mass of 1 mole of carbon dioxide would be 44 gram and the mass of 2 mole of water vapor would be 36 gram. Limiting reagent. If we perform any chemical reaction, then it is very difficult to take exact required amount of reactants in that reaction. The amount of some reaction could be less or more than the required amount. So in this condition, after the completion of chemical reaction, the amount of reactant which had less than the required amount gets completely consumed. But the reactant which has more quantity remains left even after the reaction is over. So the reactant which get exhausted first, we call it as a limiting reagent, because it decides how much product will be formed in that reaction. Reactions in solutions. In most of the reactions, the reactant are used in solution form. So it becomes very important for us to know the concentration of that solution. So we can represent the concentration of any solution in these 4 ways: mass percent, mole fraction, molarity and molality. Before we understand these 4, let us know what is solute, solvent and solution. A solute is a substance that gets dissolved, and a solvent is a substance in which the solute is dissolved. And the mixture of both of these is called solution. By mass percent, we get to know what percentage of any solute is present in that solution. To find a mass percent of a solute in a solution, we divide the mass of solute by the mass of the solution and multiply it by 100. Mole fraction. This is exactly the same as mass percent. The only difference is that instead of mass of solute and the solution, their number of moles is taken. To find the mole fraction of the solute, the number of moles of solute is divided by the number of moles of solution. Similarly, we can also find the mole fraction of the solvent as well. Molarity. It is the most commonly used term to denote the concentration of solution. So we can define molarity in this way. The number of moles of solute present in 1 liter of solution. For example, 1 m NaCl means there are 1 mole of NaCl molecules present in 1 liter of solution. Now suppose that we have to make 0.2 m NaCl solution from 1 m NaCl solution. 0.2 m NaCl solution will form when 0.2 mole of NaCl molecules are present in 1 liter of solution. So if we take 200 ml of solution from 1 liter of 1 m NaCl solution, the number of NaCl molecules in it will be 0.2 moles. Because there are 1000 ml in 1 liter and there is 1 mole of NaCl molecule in 1000 ml of solution. So 200 ml will contain 0.2 mole of NaCl molecules. Now if we add 800 ml of water to it, then the total volume of our solution will become 1 liter. And the number of NaCl molecules in this new solution would be 0.2 moles only. So in this way we have made 0.2 m NaCl solution from 1 m NaCl solution. There is also a simple formula for this calculation. M1V1 is equal to M2V2, in which M1 and V1 represents the molarity and volume of new solution. M2 represents the molarity of existing solution and V2 represents the required volume of existing solution. So by this formula we get the required volume of 1 m NaCl solution as 200 ml. Here the volume of the new solution, that is the value of V1, will always be 1000 ml. Molality. We can define this as number of moles of solute per kg of solvent. So that's all for now. Hit the like button if you liked this video, and for more videos like this do subscribe this channel and don't forget to press the bell icon. From next video we will start a new chapter and learn about atoms.